Good morning or afternoon, depending on when you're watching this. This is Lesson 3, Cycles of Matter, of our first unit on ecosystems. So we are going to begin with the law of mass. And the law of mass states that matter is neither created nor destroyed during any chemical or physical change. And I know that seems complicated and that seems hard to comprehend. So what we're saying is matter as in atoms. Atoms cannot be created, atoms cannot be destroyed, atoms are only changed. Atoms are only altered in whatever state they're in. So I'm going to start with a piece of wood. And if you were to burn that piece of wood, or even a piece of paper, and if you were to burn that piece of paper, the piece of paper or the piece of wood itself would be changed or destroyed. But the atoms inside of that piece of paper or piece of wood would be the same. They would just be altered in some way. So the piece of paper would be destroyed, but you would be left with ash, and you would be left with smoke up into the air. So the matter itself changes. The paper and the atoms in the paper have turned into ash. The atoms in the paper, some of them have turned into smoke or pollution, but the paper's destroyed, but the atoms themselves are just altered or changed into something else. The wood is the same way. If you burn the wood, you end up with charcoal, and the same thing, you get smoke. So the atoms have turned into something new. The wood's destroyed. The wood is not the same. You have a chemical change, but the mass or the atoms have not been destroyed. They are just changed into something new. Other things, when you rip up a piece of paper or you chop wood, the matter just gets altered again. It just gets smaller. So it's the same wood, the same paper. It's just altered into a smaller state. Okay? Same thing happens with water. You can freeze water and turn it into ice. You can then hold that ice in your hand and turn it back into water. You can then boil that water and turn it into steam. You have not lost any atoms, you have not lost any matter, you've just changed it from one form to the next. So the law of conservation of matter is that you have not created or destroyed any matter in this process, you've just altered it or changed it in some way. This is going to be important later. Law of conservation of energy is similar. This states that energy is not created or destroyed, it is just transformed or changed or transferred in some way. So, in photosynthesis, the sun's energy is transformed inside of a plant, and that plant then transforms that energy into sugars for the plant to use. And then when you eat that plant, you are then taking in those sugars and using them for you to use to do whatever it is that you're doing. You're breathing, you're thinking, your heart's beating, your muscles are moving. You're using those sugars in some way. So the sun's energy transforms into the plant through photosynthesis. You eat the plant, and then you transform that energy into the energy of motion and digestion and whatever it is that you're doing. So the energy is just moving from one form to the next. You didn't create energy, you just changed energy. Okay? Same thing happens in the energy in gasoline. You put gasoline in your car or in a lawnmower, and the energy in that gasoline gets transformed or changed into mechanical energy, and it makes the lawnmower or the car move and go, and the engine works and it does something. The lawnmower cuts the grass, or the car moves and the engine moves and the car goes. Okay? Last example I have, the energy in food that you eat. So you've eaten food, and that food gets transformed into you and allows you to do all the things that you do. You digest, you think, your brain works, your muscles move. If you play soccer or you play the violin, all of these things involve motion and thought and precise tiny motions, and all of that is coming from, and all of those, that requires energy, and all of that energy comes from the energy you put in. So you've just transferred the energy from the food that you ate. That food had energy, and you've just transferred it into the energy that you are putting out through those activities. So that's the law of conservation of energy. You've not created energy, you've just transformed it into some new way. So what does this have to do with this part of cycles of matter? So all of this is just a cycle of energy, a cycle of matter. With the law of conservation of mass, law of conservation of energy. So in the water cycle, you can see in the picture, we're starting over at the part with the sun, and the sun heats up water, which is energy. Sun heats up water and that's evaporation, and it turns it into clouds. And then those clouds condense that water and turns it into little water droplets. And eventually the clouds get really heavy and you get rain or snow or sleet or hail. That's precipitation. And that water rains down, and some of that water seeps into the ground as groundwater. And then the process sort of starts all over again with evaporation, condensation, precipitation, water comes down into the ground over and over. I feel like I can kind of go a little bit quicker on this because you've learned a lot of this at some point in your schooling. So precipitation is rain, snow, sleet, or hail. 91% of the Earth's precipitation falls onto the ocean. And that's not because it rains more over the ocean. That's more because most of the Earth is ocean. And so most of the Earth's water is going to fall back onto the ocean. 9% of the Earth's precipitation falls onto fresh water and land. And that's more than enough to suffice our needs if you live in an area that's already receiving land. If you're living in the desert, you aren't getting rain anyways. Okay, and any form of liquid falling from the sky is considered precipitation. So rain, snow, sleet, hail, all of that is precipitation. Evaporation is the opposite process of precipitation. This is whenever the sun's heat changes water into water vapor. Okay, so there is an energy output or input into this. The sun is using energy to cause water on Earth to evaporate into the clouds. Okay. Condensation occurs within the clouds, and this is whenever the water condenses or cools down inside the clouds. This is what causes clouds, and the water gets cool enough that it turns back into tiny little droplets. And whenever the water condenses, then it rains down. So you get groundwater. And groundwater is probably the only one that you didn't know from here. Groundwater is literally water that's on the ground or underground. And this is water that isn't on the surface of the ground, but actually seeps down underground. So under the soil, below the soil. This is water that gets into the rocks, into caves, into porous rocks. This water is very important. This is where we would be digging if you were to dig a well. If you had a well on your property or well water, this is where well water comes from, is groundwater. That water can be stored for hundreds or even thousands of years. This is like our backup water or emergency water if you had a drought. Eventually, all of this water finds its way back to the ocean. Unfortunately, because of droughts in places like that have been experiencing droughts, places out west in California and Las Vegas and things like that, our sources of groundwater are being depleted. So we have to watch out for drilling too many wells that our groundwater sources are running low. So water and life, all living things contain water. Most of your body, about 70% of all your cells contain water. You regulate your body temperature through perspiration, that's sweating, and evaporation. And then when your body perspirates and sweats and water evaporates from you, that's called transpiration. And plants do the same thing. When water evaporates from a plant, it's also called transpiration. So just another way or another word for evaporation is transpiration. So if it evaporates from a puddle, it's evaporation. If it evaporates from you or a plant or a living thing, it's called transpiration. So now we get to the carbon-oxygen cycle. And this is a really important one that you are a main process of. Okay? So when plants, if you're looking at the trees first, plants go through photosynthesis, where plants breathe in oxygen and they give out, or sorry, I have that backwards. Plants breathe in carbon dioxide and they breathe out oxygen. You do the opposite process. You take in oxygen and give back carbon dioxide. Plants then do the opposite, take in carbon dioxide and give you oxygen. So between you and a plant, you're giving each other the air that you need. Everything's going to die. Everything's going to give that oxygen and carbon dioxide back into the soil for decomposers. And that's where this process should successfully end. And we'll get to those poor, bad processes in a minute, where the factory and the emissions come in. So photosynthesis is where carbon moves into living things through photosynthesis. So the sun and plants work together with carbon dioxide and they make sugar. And then respiration is the opposite, is what you do. Okay? You take in oxygen and you give back carbon dioxide for the plants. Decomposition is where, when we talked about this a little bit in the first lesson, and last lesson also, where living things die and fungus and bacteria and worms and things, they work to break down their dead bodies and sort of return back to the earth. Sorry, I went back too far. So combustion, we need to talk about combustion because this is a major process of the carbon-oxygen cycle. So combustion is the process of burning fuel. All fuel, or most fuels on Earth, coal, oil, natural gas, all of these things contain carbon. And carbon acts like a blanket or a hoodie. And when you get cold, you put on a hoodie or you put on a blanket to keep warm. A little bit of carbon dioxide in the atmosphere is a good thing. It keeps Earth warm. It keeps Earth at a comfortable temperature. But what we're doing, anything electric in your house is giving off heat in the form of carbon dioxide. Your car, anything burning fuel in your house is giving off carbon dioxide. What this is doing, because of the sheer number of cars and factories and houses and just production plants on Earth that are giving off carbon dioxide, this is like you getting cold and saying, I'm going to put on a hoodie and get warm. And then you're still cold and saying, I'm going to put on a coat. Well, now you're getting hot and you're saying, okay, I want to take off the coat, but you can't, because just like Earth, there's just more things emitting carbon dioxide. Now you have on a hoodie and a coat, and now Earth is just still giving off more carbon dioxide. Now on top of your hoodie and your coat, we're going to put on a warmer winter coat on top of that. Now you're sweating on top of that, but Earth is still giving off more carbon dioxide through all the houses and all the cars and all the power plants and all the factories. And on top of now your hoodie and your coat and your big parka on top of that, now we're going to put a blanket around you and you're really sweating under there. And Earth is doing the same thing. This is what's happening in climate change and global warming. And on top of that, now we're going to put a big fuzzy comforter blanket on top of you and you're really hot. And this is where Earth is right now. When we talk about climate change and global warming and the ice caps melting and extreme weather changes, that's what's going on the planet. Earth is getting way too hot. Ice caps are melting. We're getting extreme weather, just like you, if you were wearing a hoodie and a coat and a big parka and a blanket and a big comforter over top, and we kept adding more layers, you're like sweating and angry and you just can't get warm, you just can't get cool. That's what Earth is doing right now with all of this overloaded carbon dioxide in its atmosphere. Earth cannot cool down. That's what climate change is, and we're not making the process any easier. Just like you, if you could not take off those layers, you're getting angrier and you're getting hotter. Or nothing's helping Earth. We're not helping Earth by taking off any of these carbon dioxide layers. We just keep adding more to it. So combustion is a really dangerous thing happening to Earth, and we're doing this. Humans are the ones causing this. We're causing climate change, and we could fix it by two things. We could plant more plants and trees and stop cutting them down, and we could stop burning so much fuel. And between those two things, eventually the temperature would start to go down, Earth would slowly start taking off some of those layers, and we would get back to regulated temperatures. Last cycle we're going to talk about is the nitrogen cycle. And you can see from the picture, most of the nitrogen cycle occurs on the ground or underground. So the nitrogen cycle is the movement of nitrogen from the environment to living things and back again. Most of the atmosphere is nitrogen, but you can't do anything with that nitrogen. If you take a deep breath in and deep breath out, you breathe in nitrogen and you breathe it back out. You can't do anything with it. You have to eat it. Okay? You need nitrogen to build your protein and DNA. And you can't use nitrogen for anything without eating it. So the things that start the nitrogen cycle are bacteria. Bacteria start, and bacteria in the soil fix nitrogen and they make it into a usable form. Bacteria then give it to the plants. Plants then allow the animals to use the nitrogen, and then you also, if you eat plants or if you eat animals, you're getting nitrogen that way. Everything dies and goes back into the soil from decomposers, and then the process starts all over again. So it's bacteria, then plants, then animals, then decomposers, then starts all over again. Bacteria, then plants, then animals, then decomposers. That's the nitrogen cycle. But animals have to eat plants or eat other animals. Plants have to have their roots in the soil to get it from the bacteria. Okay. Final notes on all of these cycles. We started this lesson with the laws of conservation of mass and matter and energy. Because we're not creating or destroying any matter or energy, all of this matter gets recycled and reused through the environment. So the same water that you are drinking and swimming in and using is the exact same water that's been on Earth forever. It's cycled through dinosaurs, it's cycled through bacteria, it's been on Earth since the beginning of time, and it's the same water that you're using, and it's the same water that'll be on Earth forever. It's the same thing with the same carbon and oxygen that you are breathing in and out. It is the same carbon and oxygen that has been around since before the dinosaurs, and it'll be the same carbon and oxygen for your great-great-great-grandkids in the future. And the same nitrogen is the same way. It's the same nitrogen since the beginning of time, and the same nitrogen that'll be on Earth forever. All of this matter is not created or destroyed. It is just used over and over and over again. Make sure you do your Schoology assignment. All of this is working with it. Have a good day. Bye.